But before we look at fission, let's look at coily arrows. So coily arrow, there are two types of coily arrow. One is moving a single electron from one place to another place. That's why it's got a single arrow. And the second type of coily arrow is moving a pair of two electrons from one place to another place. It's got double arrow head. And that's what we use. Coily arrow is showing the movement of electron in reaction mechanism. But first, we're looking at fission. Fission means bond breaking. When you're breaking a bond, you are putting energy into the system in order to break it. Therefore, it's endothermic. Enter energy. So fission is endothermic and it's bond breaking. There are two types of fission. One is heterolytic fission and homolytic fission. So let's look at heterolytic fission. What is heterolytic fission? Well, if you have A and B and they have different electronegativity, then the covalent bond between A and B, which has two electrons, one from A and one from B, forming a covalent bond, so therefore they're sharing an electron. But if B is more electronegative than A, then the shared electron will be leaning towards B, spend more time with B. So the arrow of movement of electron will be towards B. For instance, if you have hydrogen bromide, now the electronegativity of hydrogen is 2.1 and the electronegativity of bromine is 2.8. Now that meant that the bromine, we take the bonding electron. This is the bonding electron. It has two electrons here. We go towards bromine because bromine has higher electronegativity. As a result, the movement with the coily arrow will moving both electrons to the bromine, and that will form hydrogen will have lost its electron, giving the electron to bromine. So you can see bromine has its own electron, this one, and hydrogen electron gone to bromine. That's why it's -1. This is -1, or you can write -1. Instead of putting 1, because 1 is default, we don't put 1. We just say minus. So because bromine has gained 1 electron from hydrogen. These two species are different. One is cation, so that's cation, and the other one is anion, which meant this is negative and that's positive. Because they're different, we call it heterolytic fission. That means we're forming different ions. Not the same, different ions. So that's why it's heterolytic fission. Well, first of all, hydrogen atom has got 1 proton and 1 electron. Well, the hydrogen here will be +1, 1 proton, because it's lost its electron, 0 electron. The proton is +1 in charge, and electron is -1 and +1. You can see here +1 -1 is 0, so no charge. But here will be +1 charge because there's a +1 and 0 electrons here. But what about the bromine? So the bromine will be, let's look at bromine atom and bromine ion. This is bromine atom, 35 protons. This one is 80 proton plus neutrons. That's what that is. And again, bromide ion or bromide will be 3580 as well, which means the number of protons here is 35. That's what I meant. Atoms are neutral because they have same number of protons, same number of electrons, so there's no charge. So no charge here. But when bromine gains 1 extra electron, that one will become a minus, and that's bromide, 35 protons. Now it's got 36 electrons because it's gained 1 electron from hydrogen. And the overall charge now will be -1 because this is +35 and that's -36. So because electrons are negative and that's -1, -1 times 36 will be -36. Protons are +1, +1 times 35 will be +35. And that's why it's -1 here. So when you have heterolytic fission, due to a difference in electronegativity, you get two species, two different species. One will be cation, the other one will be anion. Okay, let's define heterolytic fission. Heterolytic fission is when the bonding pair of electrons move from the covalent bond to one of the most electronegative atoms. Here's the covalent bond, and there are 2 electrons here, one from hydrogen and one from bromine, and bromine is the most electronegative atom, so these 2 electrons will move from there to bromine with a double arrow indicating 2 electrons, 1 electron, 1 electron, to then form a positive charge, that's the positive charge, and a negative charge ion, That's the negative charge ion. Now, these 2 electrons here are those 2 electrons. This is heterolytic fission. Hetero because you're forming 2 different species. Not the same species, but 2 different species. Hetero means different. And fission indicating breaking, bond breaking. We have another example we could look at for this reaction is bromomethane. The electronegativity of carbon is 2.5 and that of bromine is 2.8. So those 2 electrons here are now going to bromine. That's double arrow, one for one electron, another electron, to then form carbon cation, because carbon has lost this electron, it's positive, and plus bromide ion or bromine ion, which is bromide. And here are these 2 electrons are here, one electron. So these 2 electrons is those 2 electrons here, and the minus indicating that bromine has gained carbon electron, 1 carbon electron. This is -1. So that is the definition of heterolytic fission.